This is Duke University.
So with that, I'm going to introduce our speakers. So it's Doug Eisner right here in the front. Let me just say a little bit about Doug. First of all, he's a really nice guy. I've known him for the past few years. He's very helpful to what we're doing here in entrepreneurship. And his story is kind of listed a little bit in your packets here on the front. His company is called GrassRoots Biotechnology, which he helped take out of Duke University. And Doug has a really neat background, which I think he's going to talk about in depth, but I'll just preview it for you in saying that he was actually a lawyer in New York City and actually a litigator. And so I think it's kind of a neat story that he was a litigator, then came to Fuqua, got matched with a life sciences technology and took that out and has started a company. So he's going to come up here and share his story with you and hopefully share some tips with you about how to think about your own opportunities to start a company. So let's give Doug a warm welcome. Flash, yeah. There you go. Let's stick that in your pocket or your belt.
Which is,
There you go.
Hi, my name is Douglas Eisner. As Howie said, I'm a Fuqua graduate. I came here and graduated in 2007. I wasn't really going to go into my background, but I'll briefly tell you I was a prosecutor in New York City in the Manhattan District Attorney's Office for 8 years. I prosecuted street crime and securities fraud, and then I was in a small internet company that imploded. And after I worked in civil litigation. And I came back to school because I really wanted to do something entrepreneurial. I didn't see the business opportunities in New York at the time, and so Fuqua I knew was a place where there was a lot of technology and a lot of opportunity. So I came back to school, and in the end, when I left, I formed GrassRoots Biotechnology with Dr. Philip Benfey, who is the chair of the biology department, or actually the ex-chair of the biology department, and now he is head of Duke's Center for Systems Biology. GrassRoots Biotechnology is an agricultural biotechnology company. We're focused on early stage research and development. The company was actually formed from a class here at Fuqua. It was John Field's Duke New Ventures Clinic. A team of students, including myself, wrote a business plan for a technology that Dr. Benfey had. And after I graduated, Dr. Benfey and I started the company. The company's mission is basically to create technologies to make better agricultural crops, traditional crops like corn, cotton, soy, canola, and also biofuels crops. We're very interested in switchgrass, sweet sorghum as potential crops that could make biofuels competitive with gasoline and other fuels. So that's we have basically two focuses in terms of our mission. Right now we're 21 employees. We have an office in downtown Durham, office and lab space in downtown Durham. We're right near the ballpark. We moved there recently. And actually there's another Fuqua grad who started a company from here also, who's moving in right downstairs. His company's called Precision Biosciences, Matt King. But we're downtown in the Venable building. So I'm going to tell you about GrassRoots Biotechnology, about our product, a little bit about the intellectual property and the financing. The stories, it's specific to my company, but hopefully the things that we went through will be generalizable to you when you start companies. I think every instance or every circumstance that a company goes through is probably a one-off and first seen, and so you can learn just by hearing a lot of stories about different companies. So first, I'll tell you about our product. Our research is basically focused on finding trait genes and promoters for commercial crops. So our research is is based on finding genes. This is a picture of a chromosome with the DNA, a gene, a trait gene, which might affect a particular trait in a crop, like drought tolerance or the ability to use nitrogen more efficiently or potentially increase yield. So those are trait genes, and something that I didn't know before I started in GrassRoots is there's a promoter. It's a section of DNA that's right before the gene, and that promoter tells the gene when and where to turn on and off in the plant. And so it's vital to, when you create a transgenic plant, when you put a gene inside a plant, you actually have to couple it with a promoter, so the promoter controls the expression of that gene. And without a good promoter, the gene's useless. So this is the thing that Dr. Benfey is an expert on, and this is the thing that enabled us to attract our strategic partner, which is the Monsanto Corporation. So we licensed a technology out of, is this enough?
Can you guys hear okay in the back?
Yeah. Okay. We licensed a technology out of Duke University. It was in Philip's lab, and I actually have a small, I actually have one. It's called a root array. I'll just pass this around, but I'll show it to you. This is the root array, and this was developed at Duke University. Here, I'll just pass it around. That one says retired on it. This is a tiny device. It's a little plastic system. It's actually, we have a patent pending on it. And what it is a seed well plate. There's a plate in the middle here where you can see seeds are planted and tiny little Arabidopsis plants are grown. The seed well plate is sandwiched between two chambers, two airtight chambers. The roots go down into one chamber and the shoots go up into another. And we can control the environment of the roots, the nutrient environment. We can deprive it of nitrogen. We can decrease the salinity. So we can see how the plants react to changes in the environment. And what we do is we image the roots on the backside with a confocal laser scanning microscope. And the microscope takes pictures of the roots on a section. And what's amazing is that you can actually see genes turning on and off in different sections of the root tip. And here's a typical picture of, or here's some typical pictures taken with a confocal laser scanning microscope. The red part is the plant, the root tip, and all the different cells in the root tip. And the green part is a gene that's been labeled with a marker. It's now turned on in that particular spot in the plant. And this is something that ag bio companies are very interested in, because they might have a gene that prevents like a corn rootworm borer from going up into the root of the plant, and they want to express a toxin in a specific part of the plant, maybe in the outside layer, maybe they want something in the cortex. And so this is what we can give them with our technology. We can create, we can find promoters, and also this enables us to also to locate trait genes, to find or infer the function of genes that are connected to specific promoters. These are called tissue-specific patterns of expression, because you can see that the green or the expression is only in certain tissues. That's one of the things that our partner is interested in, tissue-specific expression, and also constitutive expression, which is a promoter that can drive a gene throughout the different tissues of a plant. And here you see that happening in the upper right corner. That's the root tip, and there's a gene that's being expressed. In this case, it's a marker gene all through the root tip. So this technology was, it's owned by Duke. One thing that you should know, if you're taking technology out of Duke, if it was developed here in a lab at Duke, Duke owns it. It's not the professors, it's not the inventors. Duke has all the rights to the technology, or rather they can decide what is done with the technology. This is actually a crucial thing that needs to be addressed when you take the technology out of a university, because you'll deal with the Office of Licensing and Ventures. All the technology that's discovered here goes to them, stuff from the medical school, stuff from the biology department, computer science. It all goes to OLV, and then OLV negotiates licenses. And there are a lot of terms that you have to deal with. when you talk to OLV, we originally went in there and wanted to license that little device and spent a long time negotiating with OLV. It is not necessarily a quick process, and some of the terms that you can face or some of the issues that you deal with are patent costs. Oftentimes, OLV will want you to pay the patent costs for the invention. Initially, I think the initial, what's called a non-provisional patent filing for that root array was about $12,000. The next filing was about that. It was a year later. So OLV often will want you to pick up the patent costs. They'll often, and this is all for a license for the technology. They don't generally assign technology outright. This actually is assigned. We own it outright, but it's rare that that happens. They often want license fees. So when you take the technology, they're going to want to pay you to pay a license fee. And this will depend on the value of the technology and the state of the company that you might want to start. There will be milestones in the contract. You have to hit certain research milestones in terms of developing the technology to show that you're actually pushing it forward and developing it and creating value with the technology. And also commercial milestones, which basically requires you to commercialize the product in a certain amount of time. And each one of these milestone events is associated with another payment to OLV. And the flip side to that is that if a milestone isn't hit, OLV can actually take the technology back in some instances, which I've heard has happened, and that's something that is obviously is like a death knell for a company if it's a core technology. If a product gets into the market, OLV will often negotiate for royalties, and potentially they might want equity in the company. Now, all these things are different things that OLV can negotiate for. They're all moving targets. There's nothing written in stone. And they generally will want to work with you because they want to see companies come out of the university. It benefits the university, it benefits the public, and it benefits the inventors. Also, in one aspect, they're stewards of the technology, and so when the technology is licensed and fees come in, I think about 40% of that goes back to the inventors. So they're negotiating for the inventors also. That's one way of dealing or protecting technology or acquiring technology. The other is trade secrets. Now, trade secrets have very distinct advantages. And what a trade secret is basically a secret. You have technology that you use and you don't disclose it to anyone outside of the company. And in order for a trade secret to be viable and to be held up, you need to really protect the intellectual property. If it gets out, you have to kind of pursue the party that has it and try and retain it. But the key is you keep the technology secret. There are no patent fees, which can be very expensive. One of the aspects of a patent is that when you apply for a patent, eventually you'll have to publish that patent application, even before the patent is issued. So if you want your technology to be a secret, it's going to get out in about a year. But if you file in Europe while you file in the U.S., it's immediately published, so anyone can go see it. So that's a consideration in deciding what to do. Some technologies lend themselves to trade secrets more than others, particularly software. Software you can copyright. It's harder to patent, and there are a lot of legal issues around that now. But software kept as a trade secret is often a path you see. In addition to the fact, if I'm not a software person, but my understanding is that if people understand or know what software does and see a little of it in action, they can kind of just copy it. They can write around the code. So software is often kept as a trade secret. And also, a technology that's used within the company only, and it's used as a platform to create products, much like the root array, but the root array actually we couldn't keep that as a trade secret because there were papers written on it and it was disclosed. So once a technology is actually disclosed and out in the public, that makes patenting difficult. But we have another technology that is also a platform. It's called the gel imaging platform. This is not a great picture, but oh, by the way, if you have questions, please ask during the talk, because I think it will be more interesting if there are areas that you're curious about. This is our other technology, and what this is, what you're seeing in the picture are glass cylinders with a gel medium in them and plants growing in each cylinder. And what this enables us to do is watch the plant roots as they grow in the cylinder over the course of about 30 days. And what we can see is that different plants, I think these are switchgrass, different plants have from different areas in the country, different varieties of switchgrass will have root systems that are entirely different from other ones. Some will be shallow, some will be deep, and basically these are to adapt to the environment that they grow in. And what we're trying to do is associate different root architecture traits like root length, root volume, root number, branching of small root hairs. We're trying to associate specific traits with agronomic qualities in the plant. Maybe a plant that can deal with drought better, likely a plant with roots that can reach down into the water table. So this thing here, this is not proprietary. Anyone could put a plant in gel and grow it. But what we do keep as a trade secret, here are actually some pictures of what I was talking about. And these are all switchgrass, and they're different varieties that are grown all over the country. And you can see in the same condition, it's 20 days, you can see they have very different characteristics. And so why we kept this a secret is because we have an image analysis platform. And this is a software program that takes the digital pictures, converts them to images that the computer can understand, and then we analyze the roots. So we can do this in-house, and the reason we're keeping it as a trade secret is that we have no interest in selling the technology to someone else. We want to use it ourselves to develop better crops. We want to figure out what root traits are valuable, and we want to develop, either breed those into crops or create transgenic crops based on specific root traits. So when you look at your technology, you have to kind of evaluate what it is, what you want to do with it, whether it can be kept as a trade secret, and kind of figure out the best path, whether you want to patent it or keep it as a trade secret. And in addition, trade secrets, it's questionable whether they need to be licensed or not, but it's certainly a lot cheaper to do it that way. One thing that's unique about GrassRoots is that we didn't get any angel funding, we didn't get any venture capital funding. All our funding was initially from small business grants, and then we have our Monsanto Strategic Alliance, and that provides a significant amount of money for us to do our research. But this is a great source of funding, and you can see there's 10 agencies, federal agencies that give small business grants. The USDA, we have one from them, Department of Defense, Energy, National Institute of Health, Department of Transportation, the EPA, NASA, NSF, we have a grant from them, Department of Commerce, and the Department of Education. So all of those agencies, by law, have to give a portion of their funds to small businesses. And they give them in SBIRs and STTRs. SBIR is a Small Business Innovation Research Grant. And the purpose of these grants, the initial phase one of these grants, it's a small amount of money. Our USDA was 80 grand, our NSF was 150. The purpose of these is just to develop the technology. You can't use it to pay for patents and things like that, but it's supposed to advance the technology to another stage, to proof of concept, so then you can potentially raise money around it. And then apply for a phase two and really develop the technology. One of the interesting grants is called an STTR. Our NSF grant is an STTR grant. And the good thing about that is that it's a grant that's a partnership between a university and a private company. So when Philip and I started this company, we certainly didn't have enough money for lab space and instrumentation for biotechnology work. So we actually did it at Duke, and we paid Duke a portion of the grant to do the research. Again, that kind of implicates ownership issues because Duke owns stuff that's done at Duke. So that precipitated more conversations about technology. But the IP issues, which are critical. But if you're going to do something that has a university professor backing it, and you can conduct research within the university, it's a really good grant. Now, not all of the organizations give the STTR. All of them give SBIRs. NSF is where we got our STTR from. After you do phase 1, you apply for phase 2. It's a long period of time between the two of them. It can be 8 months or so. And the phase 2 grants can be $400,000. Our USDA grant is $400,000. Our phase 2, it's funding that gel system. It's research for roots and bioenergy crops. And our NSF grant is for $500,000, and now we're cooperating. We have a partnership with UC Davis. It's no longer due on phase 2. And the crucial thing that you should know about this is that timing is really important because the applications are due, maybe they have 2 cycles a year. The NSF, I think, was December 4th, so we had to get it in before that. Writing grants tough. It takes a while, at least a month. It takes a long time to get just the administrative things in place that allow you to submit the grant. So that's important. So it takes a month or so to write the grant, then you submit it. You can find out if you got it in 4 or 5 months, and then maybe 2 or 3 months after that, you actually receive the money. So in thinking about funding your companies with this resource, you got to be cognizant of the timing, because there's a long time between writing the grant and receiving the money, and the applications it's not rolling applications. So you got to know, you go to these agency websites, the SBIR part, and find out what their grant solicitations are and when they're due, and then what you need to do to write a grant. It's a great way to fund a company. It's free money, so it's a good thing. So we did that. The first thing that we got was, this is actually our total federal and state grants. The North Carolina Biotechnology Center gave us a loan initially, a $25,000 loan, which was very helpful because we needed to pay lawyers to kind of set the company up and just pay for things that to get the company started. Then we have our NSF grant, which is altogether $800,000. And what's interesting is that this program actually might be ending, but North Carolina, the Department of Commerce, supplements the grants that you get from these federal grants called North Carolina matching grants. And so the phase 1 part. So for phase 1, our NSF, they gave us $100,000 to match our $150,000, and it's a great program. It's very effective in kind of helping to leverage money because it's expensive to conduct biotechnology. But this is kind of how we started, and the NSF was the first thing we got after the loan. And actually now from the North Carolina Biotechnology Center, we have an industrial fellow, so they've paid for 2 years of the salary of a postdoc to work in our lab, which is another very fortunate thing for us. But what the NSF did for us is we got this grant, and we were actually negotiating with several agricultural biotechnology companies at the time. And the grant is very important because it provided a measure of validation for the technology and the company, and particularly the development that was going on. And so during our negotiations with Monsanto, we could point to that and say that the NSF has funded this technology based around promoters. And it helped us a lot, which helped us get the Monsanto grant, which is really what's funding our company now. So we have a strategic alliance with Monsanto. They are one of the most successful ag bio company right now. They're really, they have a very kind of robust research platform, so they're good partners. You can go, there's a traditional kind of route of raising money, which is if you have, you can go to angels, which are small investors who will invest $50,000, $100,000. You can usually get a pool together of up to $1 million potentially, and that's very good funding if you can get it. It allows the founders of the company to maintain control, which is important. If you start a company, you don't want to give control up to a venture capitalist right away, and so it's a really good way to start a company, but it's limited funds. So it really depends on what you're doing. Now, if you're starting a software company, you don't need a whole lot of money. It's not infrastructure is not a big deal. You don't need labs and chemicals and microscopes and things like that. So you need computers and some space and some smart people to develop products for you. So angel investing can be very effective for certain types of products. And also in biotechnology, it can, if you have a product where you just need a little more development in order to kind of bring it to the next step, you can get space in an incubator cheaply, maybe hire a technician and work off the angel money until you kind of prove the product, prove that it's valuable. And then you can potentially create a strategic partnership or VC funding. Venture capital funding is, the first round is anywhere from $5 to $25 million. 25 is on the high end. One of the things about VCs is that they're looking for companies that are a little farther along. And I think a trend that's occurred over the last 10 years, given the internet bubble and the state of the credit markets, is that venture capitalists are now looking for companies that are farther along. So you're going to need probably a technology that's more proven, more ready to go. You have to have a very strong IP position, intellectual property position. So they're going to want to know that you have the technology locked up. And at that point, they'll invest. VC funding can be very helpful. You get a company going very quickly, but the big trade-off is loss of control. Oftentimes, they'll want to gain control of, really take control of the whole company and have the majority stake. Sometimes it will be lower level of control, but they're going to want to make sure that their money is used in the way that they see fit. So it's a good source of funding, but again, everything has trade-offs, and that's, our way has trade-offs. VC funding has trade-offs. Another thing you can do, and depends on your technology again, is bootstrapping, which is basically self-fund the company. It depends on the technology again. If you're doing IT stuff, you can possibly bootstrap, and you can develop your technology. If you're close to developing a product, you can then, oftentimes you can use your own money, and maybe friends and family's money, wisely hopefully, to develop the product. So that's an alternative way of funding the company. But as I mentioned, everything has trade-offs. So also, those are kind of the two really crucial issues that you'll deal with in starting a company: the intellectual property and the finance. You deal with those. But one of the things that I like a lot about being a startup and running the day-to-day operations is I get to deal with a lot of different issues. When I was a lawyer, particularly a commercial litigator, I sat in my office and wrote briefs around one issue, and didn't talk to many people, and found it it just was not for me, I guess. So one of the things that I deal with, human resources, it's actually compensation structure is kind of a tricky issue. How much do you pay people? When we started, we didn't know what a postdoc with 3 years experience in a lab gets or what he should get, and the information is not readily available. So there's a great network of people, ex-Fuqua people. I mentioned Matt Kane earlier, and Jonathan Gindis, also a Fuqua student who has started a company to get kind of benchmarks in terms of salary and equity. And equity is very important because you want the people who work in your company, you want them to be motivated by the success of the company, not just the salary. You don't want them just coming in for the salary, but you want them coming in to think, well, if we do well, I may really benefit from this. So equity is an important part of compensation. One of the other tasks that I've done is negotiate contracts for some of the key employees. We hired a director of research and some other people, and that's something that I do. I deal with accounting and financial management. We're basically 19 scientists and 2 non-scientists, me being one of them, and the accounting manager is the other. So the accounting manager and I, we deal with the keeping the books and the financial statements and actually kind of forecasting to make sure that we're in the right place financially for the future. And actually, that's another issue that you may or may not deal with if you start a company in the biotechnology or any other science space. You might not know the technology. When I went into GrassRoots, I really didn't understand what these guys were talking about. And it took a real long time. I had to read a lot of biotechnology and genetics book. I actually took a class here at Duke, molecular biology and genetics. That helped, and talked a lot with scientists. They often, looked at me like I was clueless and had no sense because I didn't know what different aspects about DNA or promoters and things like that. But that's an issue that you can deal with, but it's important to learn the technology enough to definitely be able to talk about it and to understand it as well as you can. And I think that over a course of time, if you're steeped in agricultural biotechnology, for example, and you're talking about it all day long, eventually you're going to get it. And I'm almost there, but hopefully I'll get it soon. But right now I don't sound as bad as I used to when I talk about it. There's a ton of legal issues that we deal with. Now, I'm a lawyer, as I mentioned, but I didn't do employment law and I didn't do intellectual property. And so we have outside lawyers who file patents for us, and also we negotiated a lease. I would do the negotiating. The lawyer would look it over. I'm starting to realize that maybe a lot of this, we probably don't need so many outside lawyers, but and we could do it in-house because we've seen a lot of these agreements, and so we can do that now. As the COO, these are kind of the things that we're going to deal with. So it's challenging, exciting to start a company. Every company is very specific in terms of the technology and the issues that you deal with in the markets. But you learn a lot. You got to learn about a market, the ag bio market, technology, and personnel issues, and financing, and all those things. And so that's why I really enjoy the job. And hopefully I'll be around in a few years and be able to tell you about more successes in the company. So that's where we are at this moment.
That's great, Doug. Let's give him a hand. So we're scheduled around till 8. We have 10 more minutes. I'm going to open it up to Q&A for 10 minutes, and then we'll officially end the session at 8 o'clock. So open it up to questions. Go ahead.
Yeah, how does it work when you have grant funding and I guess Monsanto funding for the owner's compensation? Is that regulated, or is that?
Well, the SBIR funding is actually it's funding that's supposed to set up a small business. It's business funding. It's not. So when they, and I'm not sure I understand what you're saying, but so
basically, like, how do you decide how much you get paid? I mean, obviously there would be a conflict of interest there. You want to make more money, but is that...
Well, the funding, these grants, the SBIR, they're in our name. The STTR is in our name, and the university, we decide to give a chunk to the university, and we determine what chunk we give them. It has to be, I think, 30% or so, and then we're not allowed to pay ourselves with that. We can pay scientists. So the money really needs to be focused towards product development, and so that kind of that deals with some of the conflict issues that may arise. I couldn't take a salary off that, so that was an issue. But the matching grant from North Carolina, we're free to use that money in different ways. I'm not sure if they're continuing that program. It's something that's being debated in the North Carolina legislature, the matching grant. But that's kind of how you deal with it.
Before we take the next question, let me just make one announcement. There's a feedback form on the back of your packet. If you all wouldn't mind just taking that and ripping it off the table. We really need your feedback to just kind of let us know how the event went and help us to continue to improve. So please fill that out during this Q&A session. I saw several hands there. We'll go right here.
How does the tech transfer office determine who they're going to license the technology to?
That's an interesting question.
Can you repeat the question actually?
The question was, how does the tech transfer office decide who they're going to license the technology to? With regard to different technologies, they might try and go out and find the highest bidder. Some of the drug technologies, the pharmaceuticals, and things like that, they might shop the technology around and see who they think can commercialize it and get royalties back to the university, or see who's going to provide the most, give them the best deal. But they're interested in the partner that's going to take it and their ability to develop the technology. In our case, we were the only ones looking at our technology. Also, they favor inventors inside the university. So if you're an inventor and you want to take a technology out, you're in a better position to license that from the university as an inventor. So that's one of the other considerations that they have.
How did you meet your partner, and where did this idea come from for the company?
Well, we started in the Duke New Ventures clinic. John Fiel, he taught it. I think he teaches another class now.
That's now morphed into the program for entrepreneurs.
So the way it started is just like a typical class. I got stuck in a group with a team with 3 other people. Stuck is not the right word, because I really liked the guys that were in the team, and I thought they were great. And then we were just assigned the technology, and we were assigned Dr. Benfey's technology, and so we had to understand it, and none of us understood it for quite a long time. And then it was really about biofuels, so we wrote a business plan around biofuels. But the plan that we wrote, and then we took it into the startup challenge. Didn't get past the first round, but the plan is pretty much what we followed. I mean, it was the idea of getting grants and then using those to get a strategic partnership. It's kind of the model that we followed, but it was just circumstance. And when I graduated, I talked to Dr. Benfey, and he wanted to start a company. I did too, and it seemed like a good opportunity.
Yeah, actually, that's my question. Another question I have is, did you initially look for a business venture to start in biotechnology, or did you also consider, a bunch of different fields?
Doug, do you mind repeating that for people?
The question was, did I look for a specific technology to start a business in, or did I consider other fields? I guess what was the motivation to go into ag bio?
Right.
Really, the motivation, I was not as concerned with the technology as I was concerned with the business prospect of it. So one of the things that I did between first and second year at Fuqua was that I was an intern at the Small Business Technology Development Center. It was actually a really good opportunity because they assigned me to 2 companies, and I got to see 2 technologies. One was a target for cyclotrons to make more radioactive fluorine for PET scans. Another was a website to treat heart care patients. And so it was actually a really good experience because I could look at the markets and judge those companies and see whether I thought they can make a go of it. And I also wrote a business plan for another professor at Duke, a computer voice recognition technology. So that's kind of something that I would really recommend. If you're interested in kind of finding out about how to judge a company and determine what would be a good company to start, you should look at a lot and write plans around them, and you'll be able to poke holes in the business model or the market and decide, maybe this is a great product for a small market. It really couldn't create anything that would be sustainable. So that's a good thing. But I know, in a million years, I never thought I was going to wind up in an agricultural biotechnology company. I didn't even know what sorghum was. I don't know if any of you do, but it's not something that we did a lot of in New York City. I like technology. It's really interesting. Dr. Benfey, he's a world leader in plant biology. So I could, one of the things is that I could see how, without understanding what he was doing, I could see how people reacted to him and the papers that he was writing and the success that he was having, and I realized that he would be a really good partner to start with. So it was, I was able to judge the opportunity, and I was kind of lucky that it was the right opportunity. But it's important that you kind of are able to look at it and judge it and see if it's the right one. So when you find that kind of lucky circumstance, you can make a intelligent decision. So.
One more, last question. I have a two-part question about funding. I understand that writing these grants takes a lot of subject matter know-how. One, how did you acquire those, I guess, the best practice for writing grants to get those funds to start your company? Second part is, can you share some best practice or lessons learned from your experience in attracting angel investors and VCs?
Well, the first thing about the grants, I didn't write any of the science. I couldn't. Philip wrote the science portion of the grant, which for phase one is really the major portion of the grant. There's a business section that's kind of a truncated business section, but it's really about the science in the first part and a little bit about the business potential. So if you're kind of coming new to a technology, you really can't write a federal grant around it. You need an expert to write the grant, but there's a lot of things that need to be done along with that. Just getting certain tons numbers and CCR numbers and getting the company ready to submit the grant, and then kind of putting everything together. So I did a lot of that, but the scientists write the grants. The second thing is that we really didn't. We went and talked to a venture capitalist before initially. Actually, when a bunch of business school students, we all went and talked to a VC and kind of saw the reaction and saw that it wasn't a likely avenue for us. So
How about angel investors? Did you guys go out and look for them?
we didn't at that time because the $25,000 grant from North Carolina Biotechnology Center that enabled us to do the small things that we needed to do, like travel to St. Louis to negotiate with Monsanto, and to hire lawyers to incorporate the company, and things like that. So we didn't approach angels, but actually right now we're thinking that might be something that we want to do, to approach angels around this biofuel space and potentially raise money around that. So we're considering that. So I'm not sure how to do that. I think you gotta go to these angel networks, which exist all over the triangle. Friends and family, if they trust you, are a great source. But it's tough to sell to VCs. I know that, but I really don't have any expertise in that area.
Very good. Doug, thank you very much for spending the evening.
Produced by Duke University. Online at duke.edu.